Alrighty, let's go here. We've got inverse functions. We want to see what we can do with inverse functions. So hopefully by the end of this, and hopefully you've been listening to this, because maybe I'll throw in something else that might be worth your while. Anyways, let's go ahead and find the inverse of function or a relation and determine if two functions are inverse. That is your goal for the end of this one. Now, how will this work? What are inverses? Inverses are simply an exchange of coordinates of an ordered pair. Basically, you switch to the x and the y. You got that? It's just a little switch. Not a problem. It's super easy. Okay, so let's take an example. Let's start off with some points. So I give you a triangle. Let's say these are the points of the triangle. 1, -2, 2, 5, and 4, -1. Find the inverse. Well, gee, that sounds hard. All you got to do, though, is switch them. So instead of being 1, -2, it becomes -2, 1. By the way, we're going to use A prime, B prime, C prime for those of you who wanted to remember your geometry days as our way of showing the inverses. Oh no, geometry is back. Anyways, let's see, 2, 5 would become 5, 2. And 4, -1 would become -1, 4. Yes, I know, this is very complicated to make sure I switch the x's and y's. Now, not that you have to do this, but I'm going to show you by a little freehand thing here. Here's the first triangle. You can see me drawing the first triangle. And then if I draw the second triangle, which really got way distorted based on the way I draw, you can kind of see, what you should see is that this right here, the green one, the original, got rotated, turned for every season. Turn, turn, turn. Anyways, that song's going to be stuck in my head now. So you can kind of see, like, what happens with inverses is that there is a rotation to them. That they basically rotate the function. And I'll show you that with another example in a second. And they're rotated about y equals x. Alright, so when we have an inverse, we usually will define it with a -1. -1 basically means you took the inverse, which in a sense means reciprocal. And we'll talk more about the whole -1 power later, but anytime I say inverse, f of x is the original, f -1 of x is the inverse. Alright, so let's look at an example. Here is my function. F of x is equal to 2x minus 5. Okay, find the inverse. Find f1 of x, -1 of x. Okay, what do? Well, make it easy on you, not that you necessarily have to do this, I'm going to change the f of x to y. So we can go back to y for a minute. Now I'm going to switch the x and the y. Switch them. Now I got to solve for y. Gosh darn dang nab, I already had y by itself. Now you got to tell me I got to solve for it again? Yes, I am. So, got to move the 5 over to the other side. So the opposite of a -5 is a +5. So I now have x plus 5 is equal to 2y. Then I got to get rid of the 2 by dividing by 2. So I now have x plus 5 divided by 2 is equal to y. Well, once I got y by itself again, then I can say that's the inverse. So that's my inverse. X plus 5 divided by 2. Not that bad. Oh, I can do that. I hope you can. Alright. Now, not that I'm going to ask you to do this, but I do want you all to see the graph. So here's the graph. The original function is the red line that you see, and the inverse is the green line. And they are rotated, although I kind of drew the line badly. Basically, if you take the gray line there, that's what they are rotated around. So they kind of curve, or they turn around that. And so you can see those are supposed to be like if you were to fold a paper on that line, they would fold on top of each other based off that line. So I guess actually I should be saying they're more of a reflection in there. But you notice there is a kind of link to them. If you saw other functions, you would definitely see this as a rotation. It turns. Anyways, let's look at another example. Oh no, there's a bell. Okay, so here I have x squared plus 1. Find the inverse. Again, get rid of the f of x temporarily. I'm going to put a y. Switch the x and the y. And now I got to solve for y. So the opposite of a plus 1, minus 1. The opposite of a square, the square root. But every time you put a square root, positive, negative. Now I've got y by itself, so that is my inverse. Easy peasy, simple, right? Okay. All right, so if you are listening right now, let me give you a secret word for today. So my secret word for bonus points on the test is star. You got to show me star in the notes, the word star, not draw a star. I want the word star, and I will give you bonus points for the next test. Aren't I so nice? All right, so now the next thing we want to do is verify that two functions are inverses. What does that mean? They are inverses if when you put them, like do a composite, like what we were doing on the last assignment, gives you an answer of x. When you do f of g, g of f, and then f of g, and you still get an x as an answer. For example, I don't get you, sir. Let me show you. Then hopefully you will understand. Here are two functions. F of x is equals 3x plus 9. G of x is equal to 1/3 x minus 3. I am going to try to do g of f of x, which means I'm going to put the g in place of the f. So I'm going to put the 1/3 x minus 3 in place of the x for the f of x function. So I now have 3 times 1/3 x minus 3 plus 9. When you distribute 3 times 1/3, there's a fraction. It's not hard. It just gives you 1x. 3 times negative 3 is negative 9, and I still have this plus 9, and negative 9 plus 9 is 0, so I'm left with just an x. Yay, that's what I want. Gf of x. Okay, and same thing. I'm going to put the 3x plus 9 now in place of the x, and I'm going to say 1/3 times 3, which is just 1x. 1/3 times 9, which is 3. And now I've got 3 minus 3, which is also just x. Yay! That's what I wanted. So that means f of x and g of x are inverses. They are opposites of each other. Yay! Anyways, let's look at another example where maybe it doesn't quite work. Okay, so here we have 4x squared and 2 times square root of x. Okay, if I put the 2 square root of x in place here, 2 squared is 4, and the square root of x squared becomes just x. Well, now I got 4 times 4, which is 16x, and I needed just x. So automatically, this is a no. No more. No. That's it. No. Okay, anyways, that's it for today. Don't forget the secret word that I told you about. Thank you so much for your time, and I hope y'all are listening and watching this at the same time. Thank you so much. Y'all take care.